Hello, and welcome to this presentation on quadratic equations. We're going to look at the practical applications of quadratics involving generation of a quadratic equation from information given in the form of ax squared plus bx plus c equals 0, which will be solved by either the factorisation method or the quadratic equation. This presentation does assume you are already proficient at solution of quadratic equations using the factorisation method and the formula. This presentation also assumes you are familiar with Pythagoras' theorem and also the calculation of the area of a rectangle and its perimeter. A brief introduction to quadratic equations. Engineers need to solve mathematical equations using standard method, and we've solved simple equations in previous work such as 3x minus 12 is equal to x minus 2, where there is one unknown in the equation. This is classified as a simple equation because there's only one unknown to solve for. In other words, x. In the above equation, we will simply rearrange for x onto one side of the equation and the constants on the other to get our solution for x, and there will be one solution. In the language of mathematics, the simple equation has one root. That's the one solution. Quadratic equations are equations that contain a squared term, such as an x squared or 3t squared, but no higher power of the unknown quantity, so no x cubed, for example. Quadratics contain two roots, as the equation has a second power, so there are always two solutions to the value of x, for example, as shown in the sketch on the right hand side. This is the quadratic equation, which is a parabolic shape here, and it has two roots to the solution, in this case a positive root shown here and a negative root shown there. So a positive value of x and a negative value of x. Those are the roots, which are the solutions to the equation. Quadratic equations continued. There are always two values which when squared produce a number. So for example, if we're given x squared is equal to 9 and we want to solve for x, we square root both sides so that x is equal to the square root of 9. When we calculate the square root of 9, we get two solutions. That's a positive and negative 3. In other words, positive 3 multiplied by positive 3 is positive 9, but also negative 3 multiplied by negative 3 is positive 9. So when we're solving quadratic type equations, x squared equations, the roots can be different, as shown above, the positive and negative 3. The roots can be equal, or one of the roots could be 0. So methods of solving quadratic equations of the form ax squared plus bx plus c is equal to 0. Method 1 is to plot a graph and note where the curve, the parabolic shape, crosses the x-axis, as shown on the previous slide. In this particular case, the roots are shown here, where the curve crosses the x-axis. This method, although illustrative, is not always particularly accurate. Method 2 is factorisation, sometimes termed the method of factors. This is normally used where the solutions involve whole numbers and requires us to factorise our quadratic ax squared plus bx plus c into two brackets. The third method is using the formula, quadratic formula shown here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Where our a, b and c are derived from the equation of the form ax squared plus bx plus c is equal to 0. Within this presentation, we're making use of Pythagoras' theorem, so we'll briefly overview it here. Don't forget Pythagoras' theorem only applies to right-angled triangles, so there must be a right angle within the triangle we're considering. The hypotenuse side always lies opposite the right angle, so in this case the hypotenuse side, the longest side, is labelled C and is opposite the right angle. Pythagoras' theorem states that the square of the hypotenuse, so in the diagram above that's c squared, is equal to the sum of the squares of the other two sides, so the sum of a squared plus b squared. We're now going to look at some questions related to practical applications of quadratics. These questions will require quadratic equations to be generated from the information stated and then solved appropriately using factorisation or the quadratic formula. These questions sometimes require inclusion of other topics such as Pythagoras theorem, basic trig, or use of standard area formulas to help generate the equations. So if you're struggling with these questions, you won't be alone. But the more you do of these questions, the more you kind of see the patterns involved here and the range and the type of equations you can be asked. So let's consider question 1p. We're told that a rectangle has sides in the ratio of 3 to 1, and the diagonal of the rectangle is 60 millimeters. We've got to find the length of each of the sides. There's a hint in the question to use Pythagoras' theorem. The answers are stated here in the brackets on the right hand side. So as a hint to show you how these questions should be approached, the first thing to do is to try and sketch the problem where appropriate. So in this case I've shown a rectangle, I've shown the diagonal of the rectangle is 16 millimeters, that's given in the question. And I've labelled my sides L and B, length and breadth. And because the question says there's a 3 to 1 ratio, I've said that L is equal to 3x and B is equal to 1x, or simply x. In other words, I'm keeping my 3 to 1 ratio. If the question said it's a 4 to 1 ratio, then I would have L is equal to 4x and B is equal to x. If you think you could attempt the problem from here using the diagram and applying Pythagoras' theorem, I would encourage you to stop the presentation and try and find the values on the right hand side in the brackets. If you're not sure how to proceed from here, not to worry, on the following slides will be the full work solution. Question 1p solution. So we're given a rectangle having sides in the ratio of 3 to 1 and a diagonal of 60 millimeters. We've got to find the lengths of each side, and the hint is to use Pythagoras theorem. And that's a difficulty with these types of questions, is to know what theory to use. So from the information in the question we can draw a sketch for a rectangle having a diagonal of 16 millimeters, having a length 3 times the width or the breadth. So in this case L is equal to 3x, B is equal to 1x, or just x. Applying Pythagoras' theorem, don't forget Pythagoras' theorem states that the square of the hypotenuse, 16 squared in this case, is equal to the sum of the squares of the other two sides. So in this case that's L squared plus our B squared. Imposing the relationships here, 16 squared is equal to L squared, that's 3x all squared, notice use of the brackets there, plus the B squared, which is x squared. Evaluating on the next line, 16 squared is 256 and 3x all squared is 9x squared. Just be careful there. Add to that the x squared term. Simplifying now on the next line on the right hand side, 9x squared plus 1x squared is 10x squared. So I've added my like terms together, and that's still equal to 256. So solving by transposition in this particular case, from 10x squared is equal to 256, we divide both sides by 10, so x squared is equal to 25.6, and then we square root both sides, so x is equal to the square root of 25.6. From your calculator, the answer is positive and negative 5.06 millimeters. As we said previously, don't forget with all quadratic equations, x squared terms, there are always two solutions, a positive and a negative, but in this case only the positive makes any sense to the question. So we're only interested in the positive 5.06 millimeters. So now going back to the original parameters in the question, the width or the breadth of the rectangle is 5.06 millimeters, that's the 1x dimension, but the length is 3 times the x value, 3 times the breadth because of the ratio given in the question, so that's 3 times 5.06, so the length is 15.18 millimeters. So those are the dimensions of each side of the rectangle in this particular case. Question 2p. Here we're given the equation W is equal to 2 multiplied by the square root of, in brackets, D multiplied by H minus H squared. We're asked to solve using factorisation in this particular case, the value of H, given that W is equal to 4 and D is equal to 5. The answers are shown in the brackets here. If you want to attempt this question before reviewing the solution on the following slide, I'd encourage you to put the value of W equals to 4 and D is equal to 5 into the equation then rearrange it into the format of AH squared plus BH plus C equals to 0. Full work solution shown on the following slide. So question 2p solution, we're given the equation for W here in terms of D and H, asked to solve it with factorisation, and we're given the values for W and D. What I'm going to do first of all is take the equation given in the question and rearrange it into a quadratic in H. So on the next line I'm going to start the process by squaring both sides of the equation. Why am I doing that? Because I want to get rid of the square root on the right hand side. So squaring the left hand side I get W squared, squaring the right hand side, notice I get 4 here, that's 2 squared, and the square root above has disappeared because when I square a square root the operations cancel. So I simply get 4 multiplied by, in brackets, dh minus the h squared. On the next line I've simply expanded the right hand side, so 4 dh minus 4h squared is expanded by the 4. On the next line I've brought all the terms onto one side of the equation, so basically what I've done is taken 4dh from both sides of the equation and added 4h squared to both sides of the equation. So I can write that now as 0 equals to 4h squared minus 4dh plus w squared. Putting in the values for d and w, I now get 0 equals to 4h squared minus 4 multiplied by 5 multiplied by h for the second term plus 4 squared. So I put in the value of d is 5 and w is 4. Just tidy up on the next line, the middle term, I get 0 is equal to 4h squared minus 20h, that's 4 times 5, 20, plus 16. I now notice there's a common factor in every term of 4, so I could divide throughout by the 4 just to simplify the numerical work. So divide the left hand side by 4, I get 0, divide the right hand side by 4, I get h squared minus 5h, that's the 20 divided by 4 gives 5, plus the 4, 16 divided by 4 gives 4. Question 2p continued. I just repeated the quadratic equation from the previous slide for convenience. So now we've got to factorise the above quadratic equation in H to find the solutions. So using the method of factors here, I first of all try and find the factors of the h squared term, so in this case that will be h multiplied by h, factors of the h squared term. And then I find factors of the constant term, so factors of the 4 in this case, and that could be 4 multiplied by 1, because 4 and 1 are factors, and that would give positive 4, but it could also be negative 4 multiplied by negative 1, because that also gives positive 4. Now because the middle term is negative in this case, negative 5h, I'm actually going to use factors of the 4 being negative 4 and negative 1. With this method we multiply diagonally and add up to see if we've got the middle term, in this case the negative 5h. So multiplying diagonally, h multiplied by negative 1 is negative h, and then h multiplied by negative 4 is negative 4h, adding up that's negative 5h. We have the middle term, so we have our factors. So reading horizontally, the factors are h minus 4 in brackets and h minus 1 in brackets. That's equal to 0. If we expand those two brackets, we'll get back to the h squared minus 5h plus 4. So to find the roots, we simply take each of the brackets individually, equate to 0 and solve. So h minus 4 is equal to 0, rearranging h is equal to 4, adding 4 to both sides, and if h minus 1 is equal to 0, then adding 1 to both sides, h must equal to 1. So our two solutions, or two roots in this case, are h equal to 4 and h equal to 1. Question 3p, similar kind of exercise to question 2p in that we've got to rearrange an equation into the form of the ax squared plus bx plus c quadratic form. It says find the value of x given that a quarter of 6x squared plus 8 plus x multiplied by a half x minus 2 is equal to x plus 6. The answers again are given in the bracket here. If you want to have an attempt at expanding the brackets, collecting the like terms together, rearranging the equation to get the ax squared plus bx plus c term equals to 0, please feel free to stop the presentation now, but the full work solution is shown on the following slides. Question 3p solution. We're asked to find the value of x given this equation here to rearrange in terms of the quadratic. So what I'm going to do first of all is expand the bracket. So I've got a quarter multiplied by the 6x squared plus 8. I've got a plus an x multiplied by, in brackets, a half x minus 2. So on the left hand side I'm going to expand now. So a quarter of 6x squared becomes 3 upon 2x squared, or simply 1.5x squared, plus a quarter multiplied by 8 is 2, so a quarter of 8 is 2, and then expand the second bracket by x times a half x, so that's plus a half x squared, and x times negative 2 is negative 2x, that's the left hand side expanded, and the right hand side remained as x plus 6. So the next line I'm going to tidy up the equation, bring my like terms together where possible. So I've got this 3 upon 2x squared, and I've got a plus a half x squared. So in decimals, if you want to think of it that way, that's 1.5x squared for the 3 upon 2x squared plus 0.5x squared. So that would give me 2x squared, so those two terms come together there. Also got a negative 2x on the left hand side and a positive x on the right hand side, so if I subtract x from both sides of the equation I will get negative 3x on the left hand side. So finally I've got a positive 2 on the left hand side and a positive 6 on the right hand side, so if I subtract 6 from both sides I will get negative 4 on the left hand side. And that's all equal to 0 on the right hand side. That's a quadratic in x, and that's of the form ax squared plus bx plus c equals to 0. So I'm going to use the quadratic form in this particular case, so I need to note what my a, b and c constants are. So in this case a is equal to positive 2 because it's 2x squared, and b is equal to negative 3, negative 3x, and c is equal to negative 4, the constant. I'm going to use the quadratic formula shown here to solve for the values of x on the next slide. So question 3p solution continued. I just repeated the a, b and c from the previous slide for convenience, and also the quadratic formula here for reference. What we're going to do now is substitute the values of a, b and c into the quadratic formula. So taking the value of b first of all, b is equal to negative 3, I'm going to put the b into the equation. So negative 3 here and negative 3 here. Just be careful of the sign change for the first term there. Now put the value of a into the equation. A is equal to positive 2, and that occurs here and here in the equation. So it's positive 2 and positive 2 going into the quadratic formula. And finally constant c is negative 4. Constant c is used here, so there's my negative 4. What we do now is evaluate that expression for x, so I'll let you wander through the actual calculations here. Just be careful of the change of sign that occurs here on the 3 because of the double negatives, and don't forget when you square negative 3 you get positive 9. Again, you have double negatives here to be aware of, so just be careful, so easy to make a mistake with these double negatives. What you should find is the value of x is equal to 2.3508 or x equal to negative 0.8508. Question 4p. We're told that a rectangular garage of dimensions 3 by 4 meters is doubled in its area by adding the same value to both its width and its length. And we've got to find the new proportions of the garage. So to give a slight hint for the question, we know the area of the garage, the final area, is going to be 3 multiplied by 4 doubled. We know that to do this we've got to add the same value to both the length and to the width. So if I called a length L, originally it was 4 meters, we're adding the value of plus x to that length, and if we take the width B, that was 3 meters. Again, we're adding the same value, x in this case, to that dimension. If you now think you could form the quadratic equation from the sketch given, I would encourage you to stop the presentation and try and generate that quadratic equation and solve it. So question 4p solution. This is for the garage that originally has dimensions of 3 by 4 meters. we're doubling the area by adding the same value to both its width and its length. Got to find the new proportions. So the original area, I've called this A0 here, would be 4 multiplied by 3, so 12 meters squared is the original area. The diagram we're using here to represent the information in the question, we know that the new length will be 4 plus x, and the new width will be b is equal to 3 plus x. So we've added the same value to both sides, and that value is x that we're trying to find. We know that the area is going to be doubled, so that's 2 multiplied by A0. So we can generate an equation now. On the left hand side, the new area is 2 multiplied by 12, doubling the area. And on the right hand side, to find the area of a rectangle, we multiply the length by the width. So in this case, the length is 4 plus x in brackets, and that's multiplied by the width, which in this case is 3 plus x in brackets. All we do now is evaluate the left hand side of the equation and expand the brackets on the right hand side. Don't forget, with expansion of brackets, we will have 4 multiplied by the 3, and then 4 multiplied by the positive x. Then we'll get positive x multiplied by the 3, and then positive x multiplied by the positive x. So on the left hand side now, 2 times 12 is 24, and then we expand the brackets, we get 4 multiplied by 3, so that's 12. 4 multiplied by the plus x, so that's plus 4x. Then the x multiplied by the 3, so that's plus 3x. And the x multiplied by the x, that's plus x squared. Simplifying and bringing all the terms onto one side of the equation, I will get x squared plus 7x minus 12 is equal to 0. I'll let you think that through for yourself. But basically on the right hand side, you've got an x squared term, you've got 4x plus 3x is 7x, and if I subtract 24 from both sides of the equation, I will get negative 12. And that's all equal to 0. Again, I'll let you think that through for yourself. That's produced a quadratic in terms of x, and it's of the form of ax squared plus bx plus c is equal to 0, and we can use that then to solve via the quadratic equation for the root x. So from above, in this case, a is equal to plus 1. Don't forget we have a 1 here we don't write, but that's a is equal to 1. The b is equal to plus 7 in this case, and the c is equal to negative 12 in this case. So you take the negative with you when you read the value of c. On the next slide, we'll evaluate the quadratic formula. Question 4p continued. I just repeated the values of a, b and c here for convenience, and also the quadratic formula. What we're going to do now is substitute the values of a, b and c into the formula. So first of all, looking at b, positive 7 in this case, so there's my b and b in the formula. So I will put the positive 7 and the positive 7 here for b. Then I've got my value of a is plus 1 in this particular case. A occurs here and here in the formula. So I'll put the value of a of 1 here and the value of a of 1 here. And then finally the constant c, in this case is negative 12. Constant c occurs here. So I put the negative 12 in this position. The rest of the calculation is all evaluation, so I'll let you wander through the calculations here. Don't forget there's always 2 roots when you solve a quadratic. In this case you should get the first root is 1.4244 meters. The second root I've got is negative 8.424, but that's not valid in this case. It is a valid root for the academic calculation. That is the second root, but in the context of this question it's meaningless. So I'm just going to use the first root found. So the length of the new garage, which has double the area, will be 4 plus the 1.4244 value. So that's 5.4244 meters. And the width b in this case will be 3 plus the 1.4244 value. So that's 4.4244 meters. So that's the new geometry of the garage that has double the area, 24 meters squared in this case. I encourage you to stop the presentation and just think through the calculation on that slide for yourself. I'm going to leave you with some practical applications of quadratic questions. So question 5p, we're given one of Newton's equations of motion here, s equals ut plus a half at squared. We're asked to solve this using factorisation for the value of t. So what you could do here is put the values of u, values of a and the value of s into the equation, and then rearrange it in terms of the AT squared plus BT plus C is equal to 0 equation. You'll find here there's a common factor of 5 that you can divide throughout by to simplify before you undertake the factorisation process. If you review question 2p solution on the previous slide, that should give you some indication of how to solve this particular problem. Answers are shown in the brackets on the right hand side. Question 6p, we're given that a diagonal of a rectangle is 150 millimeters long and the length of the rectangle is 30 millimeters longer than its width. We've got to find its dimensions. This is a similar kind of question to that we undertook in question 1p on the previous slide, in that you're going to use Pythagoras theorem here to generate the equation, and you will generate a full quadratic equation here of the form ax squared plus bx plus c equals to 0. The only thing that's different about the problem itself is that in question 1p we were given a ratio of 3 to 1 between the sides, whereas here we're told that the length is 30 millimeters longer than its width. So you need to generate the equations for length and width in terms of that piece of information. I'd encourage you to attempt that question based around that shown in question 1p, and the answers are shown in the brackets on the right hand side. Question 7p. A 2 meter length of wire is to be bent to form a rectangle having an area of 0.2 meters squared. We've got to find the dimensions of the rectangle. So in this particular case, I would suggest you form two equations, one based around the perimeter, that the perimeter of the rectangle, all four sides added together, must have a length of 2 meters, and also that when the two sides are multiplied together, the area is going to be 0.2. So what might be a good starting point here is to say call the length x and the width y, and then generate the two equations for the perimeter and for the area, and then rearrange one of the equations and put it into the other equation. So you're going to generate simultaneous equations here to help you solve this particular problem to begin with. From the substitution of one equation into the other equation, you will form a quadratic equation that you can then solve using the quadratic formula. So quite a thought-provoking question there, but I encourage you to attempt it, and the answers again are shown in the brackets on the right hand side. The full work solution for question 7p is shown on the following slides for your reference. Here is question 7p full work solution. So we're given a length of 2 meter wire, it's bent to form the rectangle having an area of 0.2 meters squared. We've got to find the rectangle's dimensions. So hint given here, the length L is 2 meters and the area A is 0.2 meters squared. We're going to generate two simultaneous equations. So from my sketch here of the rectangle, this side is called x and this side is called y, and we know the area A is 0.2 meters squared. So if I consider the perimeter, or the length of the wire in this case, that's equal to 2 multiplied by x plus 2 multiplied by y. In other words, we're adding the two x sides together and adding the two y sides together to get the full perimeter. In the next line, I've simply put the value of 2 meters in for the L, so 2 is equal to 2x plus 2y. In this particular case, you can see that 2 is a common factor in every term, so to simplify my numerical work, I could divide throughout by 2, and that's what I've done on the next line. So on the left hand side, 2 divided by 2 is 1, and then I get 2x divided by 2 is x, plus 2y divided by 2 is y. All I'm doing on the next line is rearranging the equation to make y the subject, so in this case I will subtract x from both sides, so therefore y is equal to 1 minus x. And I've called that equation 1. It's based on the perimeter length. Second equation is based on the area, which I've called A, and the area of a rectangle would simply be x multiplied by y using the notation in the sketch. Called that equation 2. So what I've generated here are two equations, both in x and y, which I can use to help me solve this particular problem. So what I do next is I substitute equation 1 above into equation 2. So the area is equal to x, and the y now from equation 1 is 1 minus x. On the next line I simply expand the right hand side, so expand in the brackets, so x multiplied by the 1 and x multiplied by the negative x. So that gives me x multiplied by 1 is 1x, or simply x, and x multiplied by negative x gives me the negative x squared term. Rearranging again to get all my terms onto one side of the equation. In this case I've taken x from both sides and I've added x squared to both sides. So we write in here, I get x squared minus x plus a is equal to 0. Just take a moment to think that through for yourself. I am taking x from both sides and I am adding x squared to both sides. All I do now is put the value of the a, which is 0.2, into the equation. So my final equation for the quadratic is x squared minus x plus 0.2, and that's equal to 0. And that's a quadratic equation in terms of x. Question 7p solution continued. I just repeated the quadratic in x from the previous slide. Notice this quadratic is of the form ax squared plus bx plus c is equal to 0. And don't forget there's actually a 1 in front of the x squared and there's a 1 in front of the x. We don't write the ones, but they're there. So now reading the a term from my quadratic equation, that will be positive 1. Reading the b term in this case, the b will be negative 1. Reading the c term in this case, that c is positive 0.2. I'm now going to put those values into the quadratic formula. Let's consider the b term first of all. I've got a b term here and here. So in my quadratic formula I put my negative 1 in those places. Be careful with the double negative at the front of the equation there, that will turn to positive. And also I put the negative 1 or squared term, but really I don't need the negative 1 there, because when you square a negative number you always get a positive anyway. So I could omit the negative from here if I wanted to. Considering now the a term in the quadratic equation, that occurs here and here. So there's my a of positive 1 into the equation. And finally consider my c term, which occurs here. My c value is 0.2 here. I will leave you to evaluate the equation and go through the arithmetic here. What you should end up with is an x value equals to 0.7236, or the x value is equal to 0.2764. As always, there are two solutions to the quadratic. Now to find the value of y, I'm simply going to substitute the first value of x back into equation 1 on the previous slide. The equation was that y equals to 1 minus x. So in this case that will be y is equal to 1 minus a 0.7236, which gives a value of 0.2764 meters. So in other words, from that equation, using the first root found, the x is 0.7236 meters and the y is 0.2764 meters. Alternatively, if I use the second root and use equation 1 again, the y equals to 1 minus x, this time that would be y is equal to 1 minus 0.2764, and that would leave us with the 0.7236 meters for the value of y. So in this case the x is 0.2764 and the y is 0.7236. So whichever root you use in equation 1, you will find the x and the y values are essentially the same. Finally, I'm just going to check the values of x and y we've calculated. To calculate the area, that would be the 0.2764 multiplied by the 0.7236, and on your calculator that should give you approximately 0.2 meters squared. So it checks. Our answers look correct. Practical applications of quadratics continue. Question 8p. An ellipse shown in the sketch has its major axis labelled A 6 meters longer than its minor axis labelled B. So this is the dimension A for the major axis across here, and this is dimension B for the minor axis across here. We're also told that the area of the ellipse is 88 meters squared. We're allowed to take pi in this case as 22 divided by 7. So we need to use that value for pi, not the value on a calculator. And the area of an ellipse is given by the equation A is equal to a quarter of pi multiplied by A multiplied by B. So in other words, using the 22 upon 7, the area is equal to a quarter of 22 upon 7 multiplied by A multiplied by B. we've got to find the lengths of the two axes. So again, we're going to generate two equations here. We know the relationship between the major axis and the minor axis. We're told in the question that the major axis is 6 meters longer than the minor axis. So there's an equation there that A is equal to B plus 6, for example. And we can also form an equation based on the area formula given in the question, noting that pi is 22.7. What we'll do is put the A is equal to B plus 6 equation into the area formula, and then we'll generate a quadratic that we can then solve. I'd encourage you to attempt that question. It's not quite as difficult as it first appears. Think it through, and again the answer is shown in the brackets here. Question 9. A concrete base has an area of 89.25 meters squared and is 2 meters longer than its width. We've got to find the length and the breadth, or the width. So again, in this case, you've got a relationship between the length and the width. We know that the length is 2 meters longer than the width. So if we call the length x, for example, and the width y, then x is equal to 2 plus y in this case. There's an equation. And you can also find the equation for the area, because you know the 89.25 is equal to the length multiplied by the width. So you can substitute one equation into another again and form a quadratic and solve. Answer shown on the right hand side, 8.5 meters and 10.5 meters. Finally, question 10p, we're given expression r is equal to, in brackets, b squared plus 4h squared, all divided by 8h. We're given the values of b is 12, value of r is 10. We've got to solve this by using the factorisation process. So what you're going to do here is generate a quadratic in terms of h, and then solve it with factorisation. I think what I would encourage you to do here is to put the values of b and r into the equation. I think I'd probably multiply both sides by 8h to begin with to get rid of the fraction, and then bring all the terms onto one side of the equation. You should have a quadratic in terms of h that you can solve then. Answers are shown on the right hand side. Here's the bibliography used to generate this presentation for your reference. And I hope this has been of help to you, so thank you for viewing.